Hello, Chapter 3, Design of Products and Services. In this chapter, we're going to take a look at the issues associated with product design and the typical processes used by companies, illustrate how different criteria can impact the design of a product, contrast how service products can have different design criteria than manufactured products, and evaluate the economic impact of a new product on a company. And last, illustrate how product development is measured in a company. So we're taking a look at product design. Companies continuously bring new products to the market. Product design is integral to success, and product design differs significantly depending on the industry. Companies often outsource major functions. Keep in mind also that there is a life cycle to products. Take a look at Apple. Apple has had an incredible life cycle with the iPhone, and the iPhone every year has a new reiteration with improved design and capability as well as different features. And generally the expectation is that after a couple of years, a product sales will begin to decline. The iPhone has been completely different than most product life cycles because it's been going on for, I think, 15 years. And the product is still strong and sales are very strong. Let's take a look at contract manufacturer. A contract manufacturer is an organization that performs the manufacturing and or purchasing needed to produce a product or device not for itself, but it's under contract with another company. What is core competency? It's the one thing that a company can do better than its competitors. And there are many companies that have specific core competencies. For instance, take a look at a company like Coca-Cola or Apple. One of the things that they do better than their competitors is the marketing of their products. In the case of Apple, when Apple is announcing that it has a new product and it's going on sale, there are lines all around the block outside their stores for people to get this product early. And there's always a buzz about exactly what this product is going to be. In the case of Coca-Cola, Coca-Cola is cola, yet it's probably one of the products that is most distributed around the world. And that's because they've got a great great marketing. So the core competency, the one thing that a company can do better than its competitors. A core competency has three characteristics. One, it provides potential access to a wide variety of markets. Two, it increases perceived customer benefits. And three, it is hard for competitors to imitate. Let's take a look at Stanley Black & Decker. The firm's core technological competency is in the 200 to 600 watt electric motors. Most of its products are modifications on this basic technology. The company produces products for three markets. Number one, the home workshop market. Number two, the home cleaning and maintenance market. And three, the kitchen appliance market. Examples of successful companies who have core competencies. Tesla Motors developed all-electric car with extended range. It has batteries that a reduced fire risk, although some may argue with that given the fact that there's been quite a few Tesla accidents and they actually go on fire and they're very difficult to put out. Has supercharging technology and also is developing self-driving technology. Moderna, we took a look at Moderna in Chapter 1. That's a company that uses mRNA medicines that send instructions to the cells in the body to make proteins to prevent or fight disease. And I think what you're going to see in the future is Moderna was at the forefront for COVID-19 vaccinations, but I think their medicines are going to be in much wider use for a larger variety of diseases and illnesses. mRNA has the potential to radically speed the discovery, development, and the manufacturing of medicines. Product development process. A generic product development process represents the basic sequence of steps or activities that a firm employs to conceive, design, or bring a product to market. Many of these tasks involve intellectual rather than physical activities. Every organization employs a different process. 6 phases of the generic product development process. Phase 0 is planning. Phase 1 is actually concept development. Phase 2, system level design. Phase 3, design detail. Phase 4, testing and refinement. And Phase 5, production ramp up. Let's take a look at Phase 0, which is planning. It basically precedes project approval. It begins with a corporate strategy. Hey, we're going to do this, or hey, we're going to do, or we want to do that. It includes the assessment of technology developments and also market objectives. Also, the output is the project mission statement. We are going to develop this within this time frame. It's going to produce this, it's going to do that. Basically getting all the specific strategic objectives laid out. And then we go into concept development. The needs of the target market are identified. Who are we going to focus on for this market, for this product, for this market? Alternative product concepts are generated and evaluated. One or more concepts are selected for further development and testing. And the concept, a description of the form, function, and features of the product. Remember, resources are limited, so sometimes the original concept of the product may need to be modified or changed due to financial constraints and market constraints as well. Phase 2, system level design. It's the definition of the product architecture, the decomposition of the product into subsystems and components. And why do we do that? Well, once I'm going to ask that question in class, the reason we do that is we have to break it down into different components so that we know who's going to be manufacturing them and taking care of them. So for final assembly scheme for the production system is usually defined. And the output, geometric layout of the product, functional specifications for each subsystem, and the preliminary process flow diagram. Now Phase 3, we get into the design detail. The complete specification of the geometry, materials, and tolerances for all parts. Identification of all the standard parts to be purchased from suppliers. The process plan is then established, tooling is designed, and then we have the output. Drawings describe the geometry of each part and its tooling, specifications of purchased parts, and the process plan. Next, Phase 4, testing and refinement. Construction and evaluation of multiple pre-production versions of the product, the same geometry and material as production version. And it's not necessarily fabricated with the actual production processes. Sometimes we have prototypes, etc., that don't go through the manufacturing process. Sometimes they're handmade and they're limited in the number of prototypes that are developed. Prototypes tested to determine if the product will work as designed. Phase 5, production ramp up. Everything's been resolved, everything's been agreed upon, everything's been laid out. Product is made using the intended production system. We obviously need to train workers and resolve any remaining problems. See if there's any showstoppers, if there's any cogs in the process, any issues with production. Are there any blockages that would be in there? Products may be supplied to preferred customers for evaluation. Hey, take a look at this, tell me what you think. A lot of times certain people, key people or VIPs or people who are social media influencers are sent products and they're asked for their feedback, and then in exchange for that they sometimes will write reviews and talk about the products. They get paid for it to generate a buzz on products that may not have a giant media marketing plan. And then last, transition to ongoing production is gradual. Variants of generic product development. Technology push products. Firm begins with new technology and looks for a market. The platform products, built around a pre-existing technological subsystem. And process-intensive products. That's the production process that has an impact on the properties of the product. Product design cannot be separated from process design. Customized products. New products are slight variations of existing configurations. High-risk products are those technical or market uncertainties that create high risks of failure. Then we have quick build products. Rapid modeling and prototyping enables many design, build, test cycles. And then the last one, complex systems. Systems must be decomposed into several subsystems and many components. Take a look at Samsung Electronics. Samsung leads with products such as TVs, mobile cell phones, fridges, washers, speakers, etc. Everything is controlled by a SmartThings app, and it targets low-end customers with simple functionality and low cost. It also targets high-end customers with AI, facial, and voice recognition. The scope of products offered makes it a global player. Summary of variants of generic product development process. So here we have generic, technology push, platform products, and process intensive. And we have the description and distinct features and some of the examples. For the generic would be sporting goods, furniture, and tools. For technology push products, we're talking about Gore-Tex rainwear, Tyvek envelopes. And Tyvek, if you don't know what that is, that's like a special plastic that is wrapped around a house after the wood frame and the outer surface are put in before you put in the wood or the concrete or the aluminum siding. Platform products are consumer electronics, computers, and printers. And then the last one, process intensive products, snack foods, breakfast cereals, etc. And again, we can look at customized, high risk, quick build, and complex. I'm going to move to quality function deployment. Quality function deployment is designing for aesthetics, and for the user is generally termed industrial design. Apple comes to mind when I think about the design aesthetics. Even the packaging for Apple is artistic. It's actually beautiful. I know that I think I've saved every single package that any Apple products that I've purchased just because it just looks so good and it's designed so well. They use interfunctional teams from marketing, design, engineering, and manufacturing. And it begins with listening to the customer, which is really important. What does the customer want? And they generally use market research for this. And it converts the expectations and demands of customers into clear objectives. And then these clear objectives are then translated into specifications, and that's how they get the product, and the customer requirements form the basis for the house of quality. Here's a completed house of quality matrix for a car door. Is it easy to close? Does it stay open on a hill? Is it easy to open? Does it leak in the rain? No road noise? And these are all coming from input from customers who are asked, what do you want in a car door? And then also there's technology as well, and that comes directly from the company's designers. Value analysis, value engineering, or VA over VE. The purpose is to simplify products and processes. The objective is to achieve better performance at a lower cost while maintaining all functional requirements defined by the customer. And it involves brainstorming such questions as, does the item have any design features that are not necessary? Can two or more parts be combined into one? How can we cut down on the weight? And are there non-standard parts that can be eliminated? These are important questions that actually will reduce the costs of the product and also improve the quality and make the product more useful. Designing products for manufacturer and assembly. The word design has many different meanings. There's the aesthetic design of a product, and there's also establishing the basic parameters of a system. Another interpretation of the word design is the detailing of the materials, shapes, and tolerance of the individual parts of a product. The traditional approach is we design it, you build it, or over the wall. Concurrent engineering. Let's work together simultaneously. The three criteria against which each part must be examined. Number one, during the operation of the product, does the part move relative to all other parts already assembled? Number 2, must the part be of a different material than or be isolated from other parts already assembled? And the third question, must the part be separate from all the other parts to allow the disassembly of the product for adjustment or maintenance? And here's the configuration of a required motor drive. You can take a look, different guide rails, etc. You can see it's attached to a screw drive, there are guide rails, connecting wires, motor-driven assembly, etc. And here's the proposed motor drive. Notice the parts. Okay, this was all engineered to go together. Then here's a redesign that simplifies it. And then we have something called eco-design. Eco-design, what is that? It's the incorporation of environmental considerations in the design and development of products or services. The whole life cycle is considered. The product is considered as a system. A multi-criteria approach is used. An extension of other important requirements such as quality, cost, manufacturability, functionality, and so on. And the application of eco-design can benefit business. How can the application of eco-design benefit business? Well, number 1, from a system design approach, it could reduce the cost of utilization of this product over the life cycle. I'll give you an example. There was a building that was made for the research center that I worked at prior to coming here. It was over $1 million. It had a beautiful lighting system. But the problem with system design in this is no one thought about the cost of replacing the lighting. And it was lighting that was about 24 feet in the sky, in the ceiling. And the specialized lighting was extremely expensive. And then also it was expensive to replace the lighting when it went out because you had to use a lift vehicle. And so that was not a good example of eco-design because there was no thought in, well, what happens after the lights deteriorate and they have to be replaced, and the cost of replacement was expensive. So it's important sometimes when looking at the total life cycle cost of products to keep in mind, well, what happens when it wears out, how are you going to replace the parts, etc. So eco-design is an important design concept that is just, lately coming to the forefront of design. Designing service products. Service products are very different. Direct customer involvement introduces significant variability in the process. And the questions to address when we're designing service products are, how will this variability be addressed? And what are the implications for operational cost and the customer experience? Here's a picture of Disney. I don't know if it's Disney World or Disneyland, but my experience with going to Disneyland many times has not been pleasant. I am not a patient person, so I'm not going to wait on a ride line for an hour and an hour and a half. And generally, if I go to these places, I go up to the customer service and I ask for fast passes. Then they try to sell me a package that I have to buy. So I say, wait, I just paid for admission to come into this this attraction, and now you want me to pay even more money so that I don't have to wait in the lines. And then I tell them it's not fair and I want the passes, and 9 out of 10 times they'll give me the passes for free. So I highly recommend you do the same thing, particularly if you're like me and you don't want to wait an hour and a half in lines to get on a ride to have 3 minutes of thrills. 3 factors when determining how different the new service is. Well, similarity to current services. New service should fit into the current service experience for the customer, and similarity to current services, to current process, even the greatest service ideas require operational support to execute. The more similar they are to the current process, the more of that support is already in place. And the financial justification. New services are costly and should be financially justified. Complexity and divergence. The complexity, the number of steps involved in a service, and the possible actions that can be taken at each step. Divergence is the number of ways a customer or service provider interaction can vary at each step according to the needs and abilities of each. The result may be a combination of higher complexity divergence on some steps and lower complexity and divergence on others. This can be used to determine different resource requirements such as worker skills, layout, and process control. Process alternatives for a family restaurant. So here's the process names, and they list out all the different things. You have reservations, seating, menus, bread, ordering, salads, entrees, desserts, beverages, service during the meal, payment, and table clearing. And then as we go through it, you can see whether or not they take reservations or no reservations. Sometimes companies have something called call ahead, which I don't understand what the difference between call ahead is and reservations. I think it's the same thing as reservations, although they're just calling it something different. I don't know. So you could just see the various aspects of this. The next slide, economic analysis of project development projects. So here we go. Economic analysis is useful in at least two different circumstances: go or no-go milestones, or operational design and development decisions. Building a base case financial model, you compute the net present value and then have good estimates of cash flow. Sensitivity analysis for what-if questions calculates change in net present value corresponding to a change in the factors included in the model, and it can be used to model different scenarios. So if we take a look at the margins, the project financials and schedule in a cash flow report, we can see that year 1, year 2, year 3, and many times these cash flow projections are important, particularly if you're getting financing for an operation or for a project. You've got development costs, ramp-up costs, marketing and support, production, and then those are all the expenses, and then you've got your sales revenue, and then it gives you your cash value. And you can see many times when you are working on a project, your cash flow initially is much lower, and then the expectation is it's going to get higher, and also your expenses are going to begin to be reduced as the product ramps up and sales ramp up. So sensitivity analysis to understand in project trade-offs. Longer product development time, it's going to cost more money if you're delayed and you don't bring your product to market, particularly if you're anticipating a product being brought in a certain quarter. For instance, if you have a record company and you have a bevy of recording artists, and you're anticipating that their album be completed in the third quarter, and you fully anticipate that they're going to sell 1 million albums, and then all of a sudden you find out that no, there's been delays, or your recording artist got sick, and you're not going to be introducing that product in the third quarter but the fourth quarter, that could complicate your revenue figures for the year, because in the one quarter you were anticipating that income, and now you don't have it. Also, if you don't have a product out in time, higher or lower sales volume, higher or lower sales price, and also higher or lower development costs. When we take a look at measuring product development performance, a steady stream of new products is important for competitiveness. Not only that, it's important for the market. If you keep introducing new products, you're going to be increasing sales, which the hope is. And if you're increasing sales, the expectation is also that you're increasing profits, and that generally Wall Street will see that as a positive, and your stock, if you are a public company, will go up as you're introducing more and more products. Firms also must respond to changing customer needs and, and competitive moves. The ability to identify opportunities and bring new products to the market is critical, and it also is a differential between successful and unsuccessful companies, because sometimes some companies are much more successful at recognizing and understanding those opportunities, and not only understanding those opportunities, but being able to capitalize on them and bring them to market. And you must also be efficient, and be efficient in a lot of areas and arenas. Generic descriptions of typical measures of product development process, time to market. There are two aspects to this. There are two aspects to this: the frequency of new product introductions and the time from initial concept to market introduction. As I stated in previous chapters, the company Zara is really good at being able to recognize opportunities and then develop those products and bring them quickly to their stores. Productivity. Such measures as the number of engineering hours, the cost of materials, and tooling costs are used in these measures as well. And then we take a look at quality, measures that relate to the reliability of the product in use, the product's performance features compared to customer expectations, and the ability of a factory or service process to actually produce that product. Some of the terms that we have: time to market, productivity, quality, conformance quality, design quality, and DPMO, or defects per million opportunities. Okay, in summary, product development is a major challenge that directly impacts the long-range success of a firm. Many companies today outsource product design to companies that specialize in different industries. And that's a key concept, because a company should recognize what it does well and what it doesn't do well. And what a company does well, they must focus on. What it doesn't do well is they must find a partner who's able to do that. Product development is a multi-step process that is unique to each organization, and different sets of criteria drive the design of a product. The criteria that relate to customer wants are fundamental, and the criteria related to cost, manufacturability, and impact on the environment are also important. Service products are different because direct customer involvement in the process introduces variability. And in conclusion, financial justification of service features ensures that customers can be retained while the company is making a profit. It is much easier for a company to retain customers than it is to go out and get new ones, because the cost of getting new ones is much more expensive than just keeping existing customers happy. Economic analysis that consists of estimating the timing and magnitude of future cash flows is used to understand the financial implications of a product development project. Sensitivity analysis can be used to answer the what-if questions that relate to project timing and costs. And generating a steady stream of new products to market is important to the competitiveness of the firm. Measures that relate to time to market, cost, and quality be used to evaluate product development success. Okay, that's chapter 3. Thank you.